Let this be alpha. Here, let me project. I'm going to project the ball. Not so it is somewhere like this. Yeah. Let this be theta. So this will be the alpha. So what will happen to this particular projectile? It's going to describe now. I think yesterday we have seen no how the trajectory in the first half. So it should be like this, no. You have to show somewhere maxima here only. So it will come and strike here. So this particular range has to be maximized. What are the conditions for it? Okay, work out no. The same similar mathematics conditions you can bring it here. It will come and strike at point B. Again, the resolving all the things. So here, if you resolve, this will be G sine alpha, G cos alpha. Similar mathematics, I think if you proceed, let me write directly the equation. Later part, you can check it. Projectile, this is a maximum range. Find the maximum range of projectile in inclined plane projected down the incline. Similarly, the same mathematics, if you solve it, no, I'll end up equation of like this: sine of 2 theta alpha plus sine alpha. Later you check the mathematics. Huh? Let me directly start from here. The same similar procedure what we did: resolve velocity, u cos theta alpha, u sine theta alpha, then get the first the time of flight. At t equals 0, it is projected here. After some time, it will be here. The similarly like what we did earlier, no, the same similar approach is what I'm going to develop here. Okay, so when this range will be maximum, so for R to be maximum, sine 2 theta plus alpha should be equal to 1, or 2 theta plus alpha should be equal to pi by 2. So theta should be equal to pi by 4 minus alpha by 2. Substitute this and solve it. We'll get the maximum range. This will be directly, shall I write? This should be equal to how much? U square G 1 minus sine alpha. This is a maximum range down an incline. You check that mathematics later on, that the same similar approach what we earlier developed, the same conditions what we can do here. No much big difference. Completed?
Yes, sir.
Okay, let's. This is about all the some theoretical ideas what I had just proposed here. So let's get into the numerical part. In the numericals again, the only standard approach is what, like resolving the velocity along the incline parallel to incline, resolving acceleration due to the parallel to incline, perpendicular incline. Now we look at the cases what all we discussed. The point of projection and the point of striking was on same incline plane. Now it may be different. Then what has to be what has to be taken care? So let's begin with this. So this is the theta 30 degrees. I'm going to throw a stone. So this is the inclined plane. So let me write find the horizontal velocity u naught, you right, u naught, so that projectile strikes the inclined plane normally. H is a given for us, theta is angle of inclination given. So it is find the horizontal velocity u naught so that the projectile strike the inclined plane normally. So what is the value of u naught in terms of h? Now look at the point of projection. It is not on inclined plane. Point of striking is on inclined plane. Okay, draw the trajectory. So now you see that come to the basics of this one. You know, if you project horizontally, what will happen to ball? It will move in a parabolic path. Now bring an inclined plane. Say rather than fighting with this diagram, you come back here. So remove that inclined plane. Without inclined plane, will you agree all of you this? So it will be parabolic path. Now when I bring inclined plane, this would be the case. So it should strike here normally. That's what here. So when you project horizontally or when you project at an angle theta, wherever may be, we know it's going to be parabolic path due to the initial velocity of projection and acceleration due to gravity. Now bring the inclined plane into the picture and get into the problem. So biggest problem for you is like a trajectory. So you know already it will be like a parabolic path. So take help of this, draw a rough diagram, then see what you can do with the condition given. So the path will be parabolic path. And it will strike normally. This is the thing. So these are there's a path, just write like this. Okay, yeah. After this, so you take, let this be perpendicular. This is theta. This will be 60 degrees. So this will be theta, no? 90 minus theta. Let me go for one more line. This will be parallel to incline. So this is the velocity of projection u naught. So 90 minus theta, this should be theta, no? Again. So this direction will define parallel, this direction will define perpendicular. Always do this setup. Parallel to incline, perpendicular to incline. Now resolve, come and resolve G. So when you resolve G, this will be G sine theta, G cos theta. Take help of this. So it was projected at point A, it will come and strike at point B. This is C, it's what I'm taking reference. So have like this, give some symbols set of for various points. So that it'll be easy for you to that you are looking at this triangle and writing the equation. So let me go for directly the time of flight. So when it moves from A to B, and the projectile moves from A to B, look at that U naught cos theta. I think what type of motion along parallel direction, along the incline. Along the incline, it will undergo retarding motion. So let me go for along the incline. So when I resolve this along the incline, U naught cos theta will come, no? Here. And if you resolve perpendicular to this, U naught sin theta. The blue color line is a path. Don't resolve that. U naught will be tangential to that only at that initial point, that one. So here, if I resolve it, so let me show blue color. U naught cos theta. Other component will be U naught sin theta. So along the incline, write the equation, no, equation of motion. It will be at B, along the incline from A to B. Don't not along the path, along the incline as it moves along the incline, as projectile moves from A to B. Okay, write the equation. So final velocity will be 0, no, here, because it is striking normally at incline, is equal to, this will be U cos theta minus G sin theta into time of flight. So what is the time taken to move from A to B? Right, like this. U cos theta by G sin theta. Keep this, let this be equation 1. U naught, no, it is U naught.
Sir?
Let's go for the other one. So sine 60.
Sir?
Sir,
Along the incline.
vertical component, here it will strike normally, no? So what is the velocity of the,
Okay, sir.
will be 0, no?
Yes, sir. Along the parallel.
So now let's define AC here. So let's look at this triangle. So what is cos theta? You can write it as AC by H from the triangle AOC. Cos theta equal to adjacent by hypotenuse. Cos theta equal to AC is equal to what? Will be H cos theta. Keep it this equation 2 in hand. So what is AC? You can write it. So shall we put that perpendicular to incline as projectile moves from A to B? Along perpendicular to incline as projectile moves from A to B. Now what is the equation for AC? You can write it as initial velocity U naught sine theta, time of flight. Now look at G cos how it will act. It will act along the U naught sine theta, no? So plus G cos theta T square by 2. Substitute the value of this is TAB. Substitute the value of TAB. Substitute, put 2 and 1 in equation 3. Then we'll get the required answer for U naught. Put 1 and 2 in 3. So AC, this will be H cos theta. U naught sine theta. This will be U naught cos theta by G sine theta plus this will be U naught cos theta whole square. Solve for everything, you'll get the value for u naught. Later on, you can substitute the value of theta. Let me bring answer everything in terms of theta. Anybody value u naught?
Sir, root 2gh by 2 plus cot square theta.
2gh by
2 plus cot square theta.
2 plus this much.
Sir, it is outside the root, sir. 2 plus cot square theta.
2 plus cot square theta will be outside the root.
Yes, sir.
Okay, fine. Yeah. I'll make correction. Okay, now?
Yes, sir.
So this will be the answer. Substitute value of theta, you'll get the required answer. That one. Yes, give that theta 30 degree, no? In that you can substitute. Completed. Let me go for next one. Just I'll scroll up so that
Sir,
you can
1
see
minute,
once.
sir.
Yeah, that one. No, I'll scroll up. Some of you are taking screenshot, no?
स्क्रीन पब्लिक है मुझे मेरे
Sir, is it a whole root, sir?
No, only this. Somebody gave answer like this. Check once. Is that final answer? Shall we conclude?
Yes, sir.
Sir, I'm getting a whole root, sir.
Whole root. Okay, when you substitute the value of theta, no?
Sir, it is whole root, sir.
Whole root.
Sir, whole root.
Mm-hmm. One plus 2 cot square theta. 2 cot square theta or 2 plus cot square theta?
2 plus.
2 plus. Okay, this will be our answer. So we'll take the next condition. There's a very best problem for students to learn things. It will strike normally. At Q. So let me write the question. Two inclined planes, OA and OB, having inclinations as shown. A stone is projected at point P with a speed u equal to 10 root 3 meter per second as shown, so that it strikes the incline OB normally at Q. So what all you have to find out? Find time of flight, velocity with which it will strike, the value of h, and distance PQ. So it is projected normally on an incline OA at point P, and it will strike the normally the other incline OB at point Q. So it's asking what is the first time taken to move from P to Q.
Sir,
Then
time is 2 seconds.
okay, no need to give answers. Please wait. Please wait. I am explaining question. Just you have to wait. No, at least. No need to give answers. Please wait. You can put in chat. So now from point P, what plane a stone is projected. So it'll go and strike the other inclined plane at point Q, and that way is saying it's normally. So read once. That one. Those are your answers. Please wait.
Sir, at Q also depth is h, sir.
Need not. It need not. Okay, you are saying same thing. Let me put somewhere here. Okay, fine now.
Yes.
P and Q are not on same horizontal line. No, earlier it was only one incline. No, now there are two inclines are there. So with respect to what we should resolve, there's a one question will come. Means, what is the reference I should take to resolve that one? So here, what you can do is like you can take the so how the path first actually the path what happen. So irrespective of that, you know that it's going to be parabolic path. So some rough path is what I'm going to show like this. This is the path. He's asking some other things. This distance also we have to work out. Okay, let's resolve G with respect to this one. So here it will be G sine 60 degree. This will be G cos 60 degree. So along OB, let me write the equation. Along OB, what is the initial velocity U? Final velocity will be 0, no? Along OB, because it's like normally on inclined plane OB. So applying equations of motion along OB. Along OB, let me write. So what is the initial velocity? The initial velocity will be along OB will be initial velocity is U. Final velocity will be 0, no? At Q, that one. So the equation will be 0 equal to U minus G sine 60 into T. So what is the value of U? U is how much? 10 root 3. 10 root 3 by 2. So solving this, we'll get time of flight 2 seconds. Try to see that along OB. Along OB applied here. So what is the initial velocity? I'll just scroll up so that looking at diagram. Yeah, that one. So when it moves from P to Q, what is the initial velocity U? U is along OB, no? And due to G sine 60, it will undergo retardation. Finally, when striking the inclined plane OB at Q, its velocity will be directed perpendicular. So therefore, what is the velocity of the projectile along OB at point Q? Will be 0. So we are writing the equation like this. Okay, fine. So once we get the time of flight, what is the other thing? He is asking to get the value of V. How to get the value of V? What type of motion? It will describe along OB, retarding motion. Along AO, because of G cos 60 degree, it will accelerate, no? Please do make observation here. To look at the point P now. When it moves from P to Q, how G cos 60 will act? Will act along this AO or along PO. So because of G cos, it will accelerate. So, and finally, when it strikes the inclined plane at Q, it will have velocity V, that one. So applying along AO now. Along AO. Final velocity is 0, initial velocity. This will be G cos 60 degree into T. This will be G, this will be 10 cos 60 degree, 1 by 2. Time of flight is what? 2. So this will be 10 meter per second. Okay, this is the expression. We got the speed. Now is asking to calculate the h. So shall we calculate first PO? So what can be this distance PO? So what type of motion is describe? What type of motion is describe along PO? Along PO is going to describe accelerated motion. So any equation for PO? PO should be equal to G cos 60 degree T square by 2. Is equal to half a T square formula. And what is the initial velocity along PO? Will be 0. Just applying equations of motion, nothing is there. So again, I'll proceed like this. Along AO, PO should be equal to G cos 60 degree T square by 2. 1 by 2, 10, 1 by 2, 2 square, 10 meter. Then can we calculate the distance OQ? The distance OQ. So now along OB, let me write once again. OQ is equal to U T minus G sine 60 by 2 t square. What is this formula? S equal to ut minus half a t square formula. So this will be 10 root 3 into 2 G by G is 10 sine 60 root 3 by 2 square. So this will be 20 root 3 and this will be 10 root 3. So will be 10 root 3 finally. Okay, I got now OP and OQ. Can you bring the PQ? So how do that total setup is a right angle triangle will appear, no? Can you calculate PQ?
Yes.
So just taking help of the triangle, I'll draw that triangle here in the end. Huh? This is POQ. So we know PO 10 meter. This is 10 root 3. Is asking to get the value of PQ. So PQ is equal to PO square plus OQ square. So you see that the problem. So will you go for remembering the formulas, expression for range, time of, they're not applicable here, no? I insisted you in the beginning of the class only. So don't go for remembering the formulas and don't try to forcibly apply a formula. Look at the situation. Is it formula what you know? Can you apply? So when the point of projection striking is same, then the initial basic formulas are applicable. When point of projection and striking are different, no, better resolve velocity and acceleration along the incline, perpendicular incline, and get into the problem. So of all, very difficult for you is the trajectory, sir. How to draw the trajectory? Assume that there is no inclined plane. Draw the trajectory, bring the inclined plane. I think you can manage to some extent with this approach. Okay, let me test you with some good question in Pathfinder. It is there. Let
Sir,
me see it. Yeah.
why did you take acceleration on second inclined plane, sir? Like G cos 60 and G sin 60.
I resolve G. I had to resolve G, no?
No, why did you not take G sin 30 and G
Will be
cos
same,
30?
no? Will be same. Say like it's going to strike the inclined plane here, no? So therefore I'm resolving with respect to the point of striking. That's all. You'll get same thing. I think you work out. You resolve G here. G sin 30. The G sin 30 is what? G by 2. Nothing but G cos 60. Fine. You resolve G either with respect to either inclined plane, you'll get the same answer.
Okay, got it.
Okay, let's. The question is that let's see that what you studied, how you are going to apply. Yeah. Now the application part has come now. Let's see that what all just now today's class I discussed now that I'm asking you to apply now. Okay, now take the question. A particle projected from the ground passes 2 points which are at H1 12 meter and H2 18 meter above the ground, and the distance D is equal to 10 meter apart. What could be the minimum speed of projection is putting question mark. Intentionally diagram also not given. Let's see, it's there in Pathfinder. Draw the diagram, draw the diagram. What is the distance? And the distance decode 10 meter apart. The distance between the points where the projectile will pass through, that particular distance is given. Okay, I'll start with the diagram. Be like this, no? So it is projected now. Is asking this particular speed. Call this, it says some beta. We don't know this angle. So what are the 2 points? The 2 points is telling you. It's a parabolic path, no? Let me draw the curve properly.
Sir, is it 20?
These are the 2 points. Let me draw the curve properly here. Oh. Okay, this is a curve. So don't, and these are the 2 points are there. This is H1. This is H2. I'll draw a red line. So this will be very important for you. Let me increase separation. So that will be easy for me. If you can draw a diagram, little bit easy for you to analyze. Huh? So this is that H2. What is that? This is what that distance, and these are the 2 points. Able to notice this? Let this be the angle of inclination alpha. Here what happened? The projectile will have a speed. Call this is theta. Are you seeing anything similar to the topic today we discussed?
Yes, sir.
So first we'll calculate alpha. So here we have a triangle. This should be h2 minus h1 by d, no? So what is sine alpha? h2 minus h1 by d. h2 minus h1, 18 minus 12.
Sir, tan alpha, sir.
Tan alpha, sorry. Or you can, tan alpha, will write it. Tan alpha is equal to h2 minus h1 by d. h2 minus h1, 18 minus 12. They are separated. Okay, d is a distance here, no? Let me go for sine alpha only. D is this one, no? Not horizontal, separated by this. This is d. Okay, now you take the sine alpha. So sine alpha, (18 minus 12 by 10). So 3 by 18 minus 12, 3 by 5. So we know sine alpha value. So sine alpha equal to 3 by 5. Keep it here. It's going to help us a lot. Then we have to calculate this u, no? That was our question. You look at that. What is the question asked? What could be the minimum velocity? What could be the minimum speed of projection that u has to be determined so that it will pass through those 2 points? Why that minimum word is brought? Because if you make the speed less than that, it may not pass through that particular point. On that one. So shall I directly bring the any how to
Sir,
yeah.
sir, then can we say that H2 is 18 and it's the maximum height
How can
or
you say
minimum
that?
speed?
Why you're saying like that? Okay, work out and see. Okay, you made a guess. No problem. Work out. Nothing wrong. Okay, fine. So first, is the diagram okay? First of all, okay. Now, let's proceed like this. Huh? So after this, look at. Let's go for this triangle. I'll just enlarge the triangle. So is this the ball? So we have projected it with a speed v. So it's come and passes through this. Okay, some problem is it? Okay, let me overcome that. Okay, this was the angle theta, this alpha. Can you remember this like a projectile? This one. So instead of this d, shall I call that as r max? So what is the value of d should be equal to now? V square by g into 1 plus sine alpha.
Sir,
Okay, now we know value of d, we know alpha, we'll get the v. After getting that v, let me finish off, then in the end you can clarify it out. So d is equal to how much? The value d is 10. V square, g is how much? G is also 10. 1 plus sine alpha is what? 3 by 5. So this will be 120. So V square is equal to 5, 8. So V square will be root of, so only 160 it is. 160. So V equal to root of 160, I'll get it. 160 meter per second. After getting that V, so I'll instead of, so what I do is like, I will go for from the point of projection to point P1. Okay, now can we apply from O to P1? So we have to calculate U. Now we know value of V. I got from that particular concept. Then after getting that, I'll apply the conservation of energy, that one. So initial kinetic energy. So rather than taking help of mathematics, no, just conservation of energy. So since most of you know this, mu square by 2 should be equal to mgh1 plus m v square by 2. M will get cancelled. So this should be equal to u square 2gh1 plus v square. So u equal to 2gh1 plus v square. Substitute the values all. H1 value is 12. V square v 160 whole square.
22.
So finally this will become 20 meter per second. This is our answer. Okay, now you can ask me questions, sir. Like, how come you brought that equation here? How they are related? Anybody?
so can you repeat?
How come that equation is introduced here? This is not inclined projectile, no? Why that inclined projectile condition is brought here? There's no inclined plane, sir. Why you are bringing inclined plane condition here? One of the student is asking like that.
Sir, why did you take D as R max, sir? Why maximum range?
That's the question I'm asking, no? Why that particular formula is introduced here? That was the question what I'm asking you.
So it is not exactly an inclined plane condition, but it's similar to that, right? That's why we can use it. But why did you take it to be R max, sir? I mean, why?
So that is the maximum separation between them, no? P1, P2, and that is equal to range. When you in a trajectory, when you draw a trajectory, what is the maximum separation between 2 points on a trajectory? That should be equal to the distance, no? The displacement. So when the projectile moves from P1, P2, So that the distance d will become like a maximum range when it is having a velocity v. I'm asking you to think here logically here. So between 2 points P1, P2, shall I say that as it moves from P1 to P2, it will move in a parabolic path. I think I should make also one thing clear. This is a path. What is that capital small d? It's a displacement. And so that is the maximum possible displacement, no, when it moves from P1 to P2. Will I agree? Maximum word. Now I'm introducing. And
Okay, sir. Let it be R maximum. But
no.
how did you say that for U minimum there will be an R max?
That is the minimum speed. What happen? You can project so that it reach point P. No, say I know velocity at point P1. I know velocity of point P1. The velocity of projection, that is V. To reach there, what you should do? You should project with a minimum velocity so that it can reach point P1. And now you can ask questions, sir, I'll project with a velocity more than this. Then it may cross P1, it may not cross P2. If I project
Okay,
with a
sir.
speed, if I project with a speed less than this, then what will happen? It may not, like it may reach P1, but it may not reach P2. It may not cross P2.
Sir, once can you explain that equation, sir?
See, when the projectile will move in a parabolic path, nothing to do with your inclined projectile. Okay, that one. Here what happens when it moves from P1 to P2, what is the maximum displacement the particle will have? Equal to d. That maximum displacement is nothing but similar to like a maximum range on an inclined plane. So I know that angle of inclination. I know the maximum range, that the maximum displacement is what? Equal to R max. The d will become like R max. So I'll find out the V. Now you can ask questions, sir, why you are writing minimum at O? That one. If you project with a speed less than that, what will happen? It will reach the point P1 with a speed other than that, what will happen? It may not cross P2. So that's why what I'm bringing the word minimum here. If I project with a speed at point 2 with a less than what I got the answer, then what happen? If it reaches point P1, it may not cross P2. But what is the condition given? So that it should cross both the points. Just logically, nothing to do with your concept. Why that maximum range on incline is brought here like a, yes, I can bring that like a, that line joining P1, P2 is like inclined plane, no? Because when it moves from P1 to P2, what is the displacement? Is equal to, and that is a maximum.
Sir, why are you telling it to be maximum displacement, sir?
See, that is only pause, so like a, what all that value, what we get is, there is a displacement, no?
Yes, sir. It's displacement.
It's a displacement, that one. So that particular value, now what when it's similar to like a, what you can say, like when it moves from, when you project a projectile up an inclined plane, then nothing but what you are asking there. What is that maximum displacement along the incline? That maximum range is nothing but maximum displacement along the incline.
Yes, sir.
Are you, you should use that language properly here. What is Rmax? Shall I put Rmax maximum range on incline or maximum displacement along the incline? Okay.
Yes, sir.
That I'm introducing here. Okay, say some questions will come where like you have to really dig into the idea, that one. See, now you know all the things. You know how to apply equations of motion. The ideas matters a lot here. You go back to maximum inclined projectile. So when you project an incline, when you project a projectile up an inclined plane, we called Rmax. What is that Rmax you call it? Maximum displacement along the incline. What is another name for Rmax you can call? That was the maximum displacement the projectile will have along the incline. Okay, similar condition is arising here, no? So I am bringing that idea and I'm putting here. Okay, so you can just it's a logic, huh? Just that logic. If you can get it, problem over. You do one thing, sir. I didn't like this method. You try another method. We discuss some problem, no? Minimum velocity to cross through a point, but it was only for one point here. Work out that method. See where you'll end up. Okay, that one. I'll stop the recording. I have another class. Okay, we'll meet tomorrow. I'll discuss few more problems on incline projectile. Then we'll proceed to the other topic. Okay, all of you.
Thank you, sir.
Thank you. Yeah.
Thank you, sir.
Yes, sir.